Welcome to Computing There I Was podcast. I am your host, Richie B. Today I'm speaking to John Cordell. John has had an impressive career. For example, he was one of the initial developers of Microsoft Internet Explorer. Hope you enjoy the conversation. Hi, welcome to the Computing There I Was podcast. Today I'm speaking with John Cordell. Hi, John. How are you?
Hi, I'm good. Good to see you, Richie.
John and I worked together many years ago. This is my first interview I'm doing in New York City. I've done some across the continent, so this is one of the few I'm doing in person. So my first question, as always, is how did you get started with computers?
Well, I started very young. I was born in Indiana, but I grew up in Mexico City.
Okay.
And when I was 14,
Mexico City?
Mexico City,
wow.
Yeah. And when I was, I guess, 14, we moved back to the States, but we moved to San Antonio, Texas. So this was a freshman in high school there. I was a bit of a chess, math, and even computer nerd, but it's like 1973. So PCs are 8 years away.
Right.
However, the school of mine had a phone connection into some mini computer in Kansas City, and we could write little basic programs. And so that was probably my first exposure there. But I had a couple of strokes of major luck in my life. And the first one was, it's a year or two later, and maybe I'm a junior in high school. I could still be a sophomore. My mother is a travel agent. She has a client who's the senior vice president of the R&D department of a local company.
Okay.
She connects me with him. Turns out he likes to hire young kids, and so I get a job as a programmer. I'm 16 years old, and it's this little R&D group, and it turns out that my boss and my boss's boss and the guy that I sat next to were the 2 and 3 guys who designed the Intel 8008, the first microprocessor on the planet. This company then asked Intel and TI if they could build that design on a chip. Neither of them could do it in time, and so this company's called Datapoint. They proceeded to build it out of a bunch of discrete TTL parts, the exact same design.
Right.
So in fact, when Intel eventually, several years later, came out with the 8008, it was instruction set compatible with the machines that we had built.
Wow. So you got to program it in assembler or machine code?
Yeah, no, it was an assembler at that point. But like the first machine I worked on had 2K of memory that was a giant shift. It was just a giant shift register. 2K.
What kind of stuff did you write?
So then I worked at that company, by the way, through every summer and Christmas, through high school, through college, and a year or two after.
Wow. Working
Working in this R&D department, the super inventive, cool guys. My mentor was amazing. Let's see. In addition to sort of inventing PCs before PCs, because by the way, this company Datapoint, the computer that they made was self-contained. It had the computer, a screen, and a keyboard all housed in a single thing. It effectively was a PC.
Right.
But they also invented a year or two after that what was then one of the 3 network topologies called ArcNet. There was a time when there was Token Ring, ArcNet, and Ethernet, and there was a battle for supremacy on that. Well, these same guys that made the 8008 invented their own network topology. So in 1976, probably 75, 76, we had 200 computers all connected via a network. They even did stuff like the company had 2 buildings. So they made a product that was called LightLink that would just shine an infrared LED across from one building to the other. They sold it to some banks here in New York, by the way.
I vaguely remember something like that. I think when I worked at Bank of New York, or maybe it was Irving, there was a building on Wall Street and on Berkeley, they used microwave link.
Okay. These guys, the reason they used light was because there's no regulation for shining a flashlight off the top of a building.
Right.
So they had done that. And anyway, so one of the early things that I did is I built sort of it was almost a little bit like a Slack, email like Slack type system just for the R&D group to communicate as we were building stuff. I wrote the linkage editor for the linker. So mostly tools I would avail. And then we had they developed their own language, and our customers would make apps out of these things.
What did the language look like?
It was called Databus, and I never really did anything in it because I was always doing the lower level stuff. But early on, I did some. I ended up doing a bunch of UX stuff. Even back then, we had a tool set, and like there'd be a trade show in Germany, and I'd build demo systems to go sell more computers, I guess.
Very cool. So where did you go to college?
So I went to UT Austin.
Okay.
So high school in San Antonio, and I went to UT Austin. I went as a declared computer science major. I think that lasted one semester. When I realized, like, wait, I'm now paying to be taught the things that they paid me to learn 3 years ago. So I switched over. I never changed my declared major, but I just started taking math classes instead. And every year I'd go to the counselor and he'd be like, hey, you're not really making much progress on your CS degree. And I'd be like, no, I'm doing math. So I ended up with an undergrad math degree.
Oh, that's cool.
Which was fun. And it served me really well because my experience was like, to a person, when you tell them you have a math degree, they're like, oh, he must be smart. Turns out if you pass 30 hours of math, you have a math degree.
Yeah, my degree is in math as well. But
did you find that same thing though? That in general, it was like, whoa. I think part of it is because it's such a useless degree, an undergraduate degree maybe, that it adds to its impressiveness.
I don't know. When I went to college, I had no idea what I wanted to do. I was good at math, so I just kept taking math, and I enjoyed it.
Right, and I did the same thing. It's because I liked it.
And the story I always tell is that I was taking physics to have science requirements, and physics got too hard for me. It was like too vague, compared to math. So I said, well, there's computer science. It's a science. I'll take that. And that was fun and easy. So I wound up having like a minor in computer science.
A minor in CS. Okay. Yeah, the math, I ended up doing a lot of tensor analysis at the end, which was sort of the intersection of physics and math. Right. So
tensors very useful today.
I know. When the AI stuff came around, I was like, oh, wait, I remember those. Although I had a professor that three semesters of tensor analysis with him, and every semester we'd ask him, well, what is a tensor? And he'd never answer. So we'd sort of decided it was like a vector on steroids or something.
It's like a matrix and more dimensions. Yeah,
exactly.
So after you graduated, you worked for this company for a while?
I worked for that company just for another year or so. And then I sort of was like, well, I'm 22 years old and I've been working at the same company for six years. Yeah. So I had a change in plans. I got a motorcycle and I decided to drive around the country on it.
Oh, that's cool.
And when I failed to maybe tighten the nut that holds the oil in enough, threw a rod and moved to New York. And then I needed a job. And so I ended up working with you there.
Right. So that was at Irving Trust?
It was at Irving Trust to call it at that point. Yeah. That was a great group.
Yeah.
It was really, I was a little bit worried coming from where I came from, which was these, people who just invented like core stuff. I'm like, oh, bank, we'll see. But as it turned out, it was like both fun and challenging and a bunch of smart people.
Yeah, I think I always was surprised how some of the technical stuff that we did at Irving. So I know you worked on the DEC 20s, right?
Yeah.
So tell me about DEC 20s. People probably don't even remember what digital was anymore.
Exactly. There existed T-shirts that said 36 bits is here to stay, right? Or I don't care what people say. I worked on DEC 20s. We built sort of home banking for a business system there. And it was sort of a fun challenge because like people could configure one of 4 languages that they were interacting with, and you had to be pretty malleable about the paths of how they might pull reports or build stuff there. So it was sort of a fun system to design. I ended up sort of defining a language that would describe the app, and then have a little compiler or interpreter that would read that and then behave. So it was fun.
Right. That wasn't Pascal, was it?
Yes. Yeah, that's right.
So how did people connect to this system? Like, so if
Yeah, we just modems, and then we had some voice device thing as well at some point that we were playing with.
well, we used this network called Telenet, remember?
Oh yeah, of course, yeah.
Right. So this is from before there was internet. There were a number of competing networks. One of them was probably called Telenet, where you kind of can connect to a local thing. You type in some number and you connect to a system.
Right.
So I don't know if you remember, but there was at one point where some kid was circling the Telenet and connected to the development system. Deck 20, the Irving.
Yeah, I was a big part of that.
Yeah. So tell the story.
Yeah. So the way I remember that is one night, as you know, computer types tend to work all hours. I think I was working really late and noticed there was somebody else on the system, and ended up initiating a chat with them at the same time as alerting like security, like, okay, there's a stranger on the system. Security, and I can't remember if at what point like police were maybe looped in, but they decided like, oh, since, by the way, this was a system that didn't actually have any money on it, so it was
development system.
It was just a development system, and even what it was developing was never doing that stuff. So it wasn't particularly dangerous to sort of give them a little rope and see if we could figure out who they were. As it turns out, though, it was probably a bad choice because while we were doing that, and I was sort of befriending them, chatting with them, being friendly, they decided to bring a reporter over to what was probably their bedroom in their parents' apartment, and show them how they could break into Irving Trust's computer system. Right. And I remember explicitly the reporter said like, oh, so could you like move money from there? To which the kid says like, oh, well, theoretically, yes.
I saw that report on TV actually.
Yeah.
Yes. No.
Exactly. Yeah, no, that wasn't the case. So at any rate, from a PR standpoint, maybe that giving them that rope was maybe not the best thing. By the way, I ended up friends with him.
Oh, really?
Yes. Yeah. We ended up with being friends for many years and would get together. And
that's funny.
He was a super smart kid.
Yeah.
Who I won't name.
Yeah, I think in the news report they didn't show his face. So. Right.
Exactly. But it was a fun thing. I ended up getting interviewed for a news thing for that piece as well.
I think what happened was, Irving said, this was only the development system, blah, blah, blah. And of course, who's going to believe a big corporation versus this kid who says he can move money around?
Exactly. Yeah. So it was exciting then.
So then 1984 came, and what happened?
So January 24th, 1984, I bought a Mac. I remember bringing it into the office and all of us drooling over it. I think right around that time is when I decided to leave the bank and basically start freelancing. Mm-hmm. I spent about 2 years writing Mac software as well as PC software for like Wall Street types. Mm-hmm. But the Mac was a fun thing, although I ended up owning 2 leases. In the early days, you couldn't actually develop Mac software on a Mac. You needed a Lisa.
Right.
So I ended up having a couple of those. But I was just a one-man shop that I called Wingtip Software.
Right, I remember.
To give it the illusion of some business orientation.
So how long did you do that? What kind of stuff?
I actually did some, there was some stuff that I did that was cool. Some of it was leveraging things that I had learned about at that first job of mine. These guys, by the way, that I worked with were just like some of the best developers. And I've been around a lot of good developers in my life since then. They were just off the charts. One of the guys, for instance, had developed a search mechanism, an associative index search mechanism, which was really quite interesting. You would hash triplets of characters, create this giant bit matrix, invert it, and you could now take a random search string, hash that, and as many bits as you got, you basically got to have this thing.
I vaguely remember you telling me about this way many years ago. Yeah.
So one of the jobs that I did when I was freelancing is Random House had their book catalog that titles and authors, and they had it on like probably a mainframe, maybe a mini by that time, and their search criteria was, as you can imagine in those days, like probably incredibly, like you had to get it exactly right. If you you left out the middle initial, no luck, right? So I built this thing. All I did was I took that. I knew how that system worked, so I implemented it on a PC, and then used it on their author title database, and sort of blew their mind, because on a PC you could type in random subsets of a word in the title and some fragment of the author's first or last name, and like instantly get the 17 hits that satisfied that. And they were a little bit like, wait, how did this happen? So there's a couple of little things where I would take some reflected glory from my mentors who were absolutely brilliant.
Cool.
So I did that. There was a fun thing. Do you remember, what was his name? Bill. He had
Bill Donner?
Yeah. Bill Donner. Cool, smart, really cool guy. He had a thing where a VAX was doing a security pair off. This was this arcane thing to where when some entity has a lot of trades of buying and selling a bunch of shares of stock, they can go through a Fed clearinghouse to transfer those, but that costs money. But if they can identify a subset of buys that add up to the share of a subset of the sales, they can clear it themselves without going through this thing, and I guess save money. Turns out it's sort of a tricky problem, given so you have basically two sets of numbers, and you want to find which subset of them adds up there. And I ended up coming up with what I consider to be a really clever algorithm for searching that space, mostly around sort of trading off time and space or something. But anyway, it was on a Mac. It was way faster than the VAXs that they were running on. And it had some cool UI where you could select stuff and pair it off. I don't think I ever put it to production, but it was good. I got paid, and it was a fun thing to write. So there are a couple little things like that. There's another one for him that was cool. It was decoding a Huffman encoded data stream. And that was another one where I felt like I came up with this cool thing that was, because it was tricky, because it's coming in, the decoder thinks a bit at a time. Sort of walking this tree with terminal nodes that are what the decoder emits. But I came up with a way of basically pre-decoding every possible thing in 8-bit chunks. Because back in those days, like bit shifting was expensive operations, and masking was expensive. And so it was a way to sort of leverage the architecture of the machines. Like they like to work in bytes, and so did that. And that thing was fun. That worked. That actually got put in production.
So at some point you left New York?
Exactly. So yeah, I did that. And then I worked at, I taught at Columbia because of...
That's right, because I took over your course.
That's right. And I took it over from our boss.
Dan Ferrugia.
Dan Ferrugia, exactly. So I forgot that you took that over. How long did you do that for?
A year or two, maybe.
Okay. That was super fun, by the way. It was like a 1-year certificate program at the Columbia School of General Studies. And everybody who came there, you didn't have to motivate these students. They were there because they wanted to learn. They were smart and interesting from all sorts of different fields.
Yeah, what I
It
liked
was a
about
pleasure.
that setup was because I taught at NYU as well, but it was just a blackboard. And it's hard to teach programming with a blackboard. Everybody had the computer, you had the computer and the screen. So I would basically, ultimately I just had the list of examples I worked through, explaining to them. And the way I did it, I would show them a program, like the animal guessing program at the very beginning in the first class. It says, by the end of this class, you know how this works.
Right. So. Nice. Yeah, I did a thing there. I started doing a thing where when I was there, they didn't have computers for the students. Yeah. It was just me, but I had a computer and a screen. And I did a thing that proved to be quite useful, which was I would literally type in front of them.
Oh yeah, that's exactly
from
what
scratch.
I did. Mostly from scratch, except there was some programs.
Yeah, a couple of things. Yeah, where it's like it was too much time to some sort of template stuff. But I felt like thinking out loud about how you write it, and or even somebody noticing oh, you make up a function and use it before you write it.
Right.
You don't necessarily notice that in a book, that that's the way your brain works. It's just make up the useful piece and worry about building it later, because I would always describe it as the whole process is to break the problem down into small enough chunks that fit in your head.
Structured programming method, remember? Yeah. And today when I sometimes advise people on how to do interviews, when they technical interviews. I said, well, when you have a piece of code that might be too complicated, say, pretend you have a function. Say, I'm going to use this function. We'll come back to it later. And let's assume it does the thing and then can solve the problem.
Exactly.
And if you have time, then you can, in an interview, you can then explain it.
The other thing that I thought was useful about that was that I would be forced to debug my mistakes in front of them.
Yeah.
And thinking out loud about that proved to be, I feel like I was always a pretty good debugger, but teaching it made me better. Because I would make up sort of advice. My biggest one was just, you have to stay on firm ground. When all the bugs that take forever are usually either multi-threaded async things or something you hold true is not actually true.
Right.
And so that idea of just be really careful to never hold true a false thing, because you can just be off in the weeds.
The cool thing about that class was by then Turbo Pascal was the thing, and you had a debugger, so you could say write piece of code, step through it line by line.
Yeah, that was so that was fun. So then I left New York to actually rejoin. So my mentor, who had hired me in high school, had gone on to found a company called Performance Technology.
Okay.
Back in San Antonio, Texas. They were a going concern. They had 30 people and had sort of built a business around, at that point, operating systems like DOS and Windows did not have networking built into them. And so we were a company that added a network stack and sold network hardware, or these ArcNet boards, the same topology. And so I joined them to do that. So
this is late 80s?
This was probably 89, maybe 90.
Okay.
Yeah, probably 90. That's when I left. So I was in New York for about 9 years. It's great. I loved it here.
So that's when the internet started hitting, right around early 90s.
Exactly.
So what happened to your ArcNet stuff?
So, this will dovetail to something later when I was working at Microsoft. But so, basically, when DOS and Windows rightly decided oh, you know what, a network stack, that's a core function of the operating system.
Right.
So I added there, and basically the business just went poof. It's there was a little bit of legacy stuff and selling into things, but for the most part, and we made some backup systems, and those still had some relevancy. But in point of fact, what happened to me next was partly tied into the fact that at one point, so Performance Technology was my company. We were sort of the second run networking company to Artisoft. Artisoft was the premier company that sold networking hardware and software. And we almost merged with them. They almost, I don't know if they were buying us, if we were just merging. In the process of that merger, which failed because the CEOs, I think, didn't get along, I met their principal engineer, and we completely hit it off. Cut to a year later, when both of those companies are they're clearly on a steep decline. My friend, it was Sam McKelvey. He had gone to work for Microsoft, to work on Windows 95. He built the server in Windows 95 that sort of put Novell out of business. By the way, his little server that was free in the Windows 95 was faster than the $2,000 server that Novell was selling. So he called me, and because we kept in touch, and he was like, "Hey, the water's pretty good here." So I went to I applied there and went to work for Microsoft, landing with me and 6 other guys who started the Internet Explorer project.
This was in Seattle?
This was in Seattle, in Redmond, which was where the headquarters of Microsoft was, which is just a suburb of Seattle.
So tell me about Internet Explorer.
So, yeah, Internet Explorer was great. Although I'll tell you one story because it's sort of fun. So first off, I was on the old side. Microsoft tended to hire really young people, and I was probably a decade older than the typical person arriving there, but it did certainly do that. And I don't know, I was quite confident. Like I've been a programmer for a long time and done real stuff. But they fly me up there, and I'm in my hotel, literally getting into bed, because in the morning I have to get up and go start this full day of interview. And I start thinking like, oh, I wonder what kind of questions they're going to ask. Only now does it occur to me, like, because and my friend is giving me he's like, okay, this is how the interview system works. It's like you go see one person for an hour. All they do is have you on a whiteboard writing code. Then you go out to a lobby. They talk about you, and to the next person, then you get handed off like for 5 people, 6 people across the day. And so I'm like, oh, I wonder what kind of stuff they ask. And I start thinking like, well, what would be a good thing to ask? And I'm like, oh, what would makes sense, like a simple consumer producer 2-threaded thing, right? Because then you have to figure out how to mutex and how to maintain take things on and off a list. I'm like, oh, that makes sense, because it's like you can describe it in 90 seconds, and then it sort of hits a bunch of things. And then I'm like, shit, I haven't done any multi-threaded stuff in a long time. And I'm like, I don't even know, but I have an NT book. So I literally get out of bed and a piece of paper, and I look up, like, what's the mutex thing? And then I have to think about it a little, but I write out this consumer producer thing. I swear to you, my first interview, the first question is exactly that. I do not mention anything about what I'd done the night before. I just go to the whiteboard and basically write it, like, as fast as I can write out the thing. So I think it was very helpful, because that gets passed along to the next thing. But I thought it was really funny. I figured I deserved some credit for guessing the question. Yeah. It was funny. Anyway, so I landed at Microsoft. Luckily landed doing Internet Explorer. I got there in late '94. We really started in earnest in probably January of '95, and we actually started. So we're in this battle with Netscape, but we haven't even started. But it turns out we went and bought a code base from Spyglass, a browser code base, as a starter set. So we didn't have to write one.
Spyglass was that O'Reilly?
No. This was, again, some of those Champaign-Urbana guys. So we bought, or Microsoft bought that code base.
This was C++ now?
Just C.
Just C, okay.
Yeah. And so we started partying on that code base, basically making a browser app. We were under an incredible deadline because it had been decided it's going out with Windows 95. And that was a ship that was leaving the harbor no matter what. It had a date and was this massive release. So I think we had like 6 months to get it there. In fact, we missed the way they locked down bits for the boxed set. We missed that. But for the golden bits that got sent to like Dells and everybody who just preloaded it on machines, we made that.
Oh, that's funny.
So although
Box sets, wow.
yeah,
Remember that?
yeah. Although probably in the early days of Internet Explorer, its main function was to download Netscape for people.
Yeah. So are you the one responsible for the blink tag?
Well, I'll tell you this way. I am responsible for having implemented it. So for IE 1 and 2, I owned the HTML engine. So I did all this stuff for that, and then I was in charge of it for IE 3, but a larger team was working on it. My boss invented the blink tag.
Okay.
And I made it. In my defense, I would say I invented the iframe tag.
Oh, now that's cool.
A much more elegant and arguably useful piece of that.
Yeah.
So, and that's actually because that's probably one of my biggest additions to HTML.
Oh, very cool.
Was that the other big one early on that oftentimes to describe people like how early in the web it was, the easiest way I've come up to do this, and I've told this 100 times, is that I have a patent issued in my name that reads basically method or system for specifying a font on a web page. So like people forget, like when we started, you couldn't even say what font you wanted on your page. It was that early. It was greenfield. There was nothing there. It was very easy to be inventive when that happened.
I guess that was even before there was CSS.
Yeah, we added CSS in IE3.
Okay.
And that was a real that was tough. The poor guy who implemented that. I was worried that we needed to ship IE3 to be competitive with Netscape.
Right.
I was really worried that the CSS stuff wouldn't be ready in time. So I made him do that entirety of that body of code under ifdef so that I could visually inspect that if that thing was turned off, the code would be unaffected. As it turns out, it did ship, and I think rightly we realized it didn't really matter if it was buggy or weird. It was like
CSS is so weird to begin with.
I agree, by the way. I mean, it was just, part of in that battle with Netscape, our take, and I think this worked out really well, was we're standards-based.
Right.
Everything that we're adding, we're either proposing it as a standard or we're taking existing plan standards and implementing them.
Did Microsoft propose CSS or was it somebody else?
I think it was somebody else because I don't know who invented that thing. It was such a weird, just off the wall thing.
I've worked with some people who are like ninjas, CSS ninjas, and it's just amazing to watch.
Yeah. Exactly. But we did that in IE3. It was pretty wonky in the early days, by the way, but hey, get your play. Okay, started.
So how did you find working on Microsoft?
I had a great experience there. So, I went in 94. I stayed there for 6 years. And honestly, part of it is, like, first off, the browser was so exciting to work on.
Yeah.
We knew it's not in retrospect, as we were doing it, we sort of knew, like, okay, this is it. This is the battle of the decade. And we knew how important it was.
Yeah.
There was also this really interesting set of attributes. We were the underdogs, right? We had
which is unusual for Microsoft, right?
Yeah, we have 6% market share. Netscape has almost the entirety rest of it.
Right.
And they're moving ahead like crazy. Yeah. And we're like, there's 7 of us. And then for IE2, there's maybe 13 of us. IE3 was maybe like 80. So we're the underdogs, but we are embedded in the world's most powerful, richest software company. And those two things combined were sort of cool.
Right.
Yeah, it was, and it was a blast to work on that. So yeah, I had a great time working on that. I did IE 1, 2, 3 parts, a little side thing of IE4. IE4, by the way, was an entirely different code base. They completely replaced all the stuff that we'd spent 2 years building, but it's what enabled the addition of the DOM, the document object model.
Right. Okay.
There's some interesting stuff there, by the way. That body of code was originally written to replace Word. It was going to be a text editing
Right.
Or word processing
Right.
thing. But because of that, they had built it with, you could imagine the APIs of selecting a subset of text and making italics,
Right.
or applying this style or stuff like that, right? And those things needed to be performant, right? Like you make that change and you want it to happen right away.
Right.
So they took that and they said like, oh, well, what if the schema is HTML? And we use the primitives that we have for doing that to expose it as an object model that JavaScript could mess with.
Cool.
So it was pretty cool. But it meant all of my code basically stopped using. That was fine though.
Yeah.
It was basically,
Did they move to another language eventually?
Did they what?
Move to another language.
That body of code was C++. Yeah. So, and then I went on to do, a group of us spent a semi-interesting year breaking our picks on the following problem. Like, hey, what if you were starting from scratch making a computer user experience and you knew about the web? Because this whole business of like productivity apps have one entire model, user model, and then the web has a completely different one. So we thought, well, if we knew about both of them, could you unify them and make one? So about 30 of us spent a year breaking our picks on that problem.
Google Docs, huh?
Yeah, I guess. Although even that seemed more like copying something.
Yeah.
As it still didn't really unify the models, but anyway, so we did that, and then I went on and worked on Messenger. Also, and interesting. Also, was a big battle with AOL for messaging, with some hijinks there.
Yeah, I guess nowadays it's Facebook, so WhatsApp or Telegram, Signal, those guys.
So I had a great Microsoft experience. A lot of people felt like when the Department of Justice came in and claimed that what we were doing was an antitrust violation, it really sucked a lot of the fun out of there. Like I had lawyers, reading all my email every 3 or 4 months, coming in and talking to me about stuff. So that was not that much fun.
Right.
And going back to, so I had worked at a small company where the addition of a new piece to the OS basically invalidated my company. I felt like, to me, the idea of adding an HTML renderer and some of the components that a browser is made up, which is what we did in IE3, we broke the browser not as an app. We made it OS components that you could use to do stuff. I felt like I had a foot to stand on to say like, hey, you know what? OSs add stuff.
Right.
I had been a victim of that once, and you didn't hear me complaining. And so to me, I felt like the argument there, the harder place though was maybe, we made a Mac version of IE and gave that away free on Macs. Mm-hmm. That one maybe is a harder case to make for like, why are you giving that away? And what's the thing there? Those Mac guys were amazing though. They were a team like a tenth the size of ours. Uh-huh. They were just brilliant. Like they were like matching us step for step. Really smart developers.
So then after Microsoft, what did you do next?
So me and 3 friends left Microsoft to do a startup. It's called Avogadro. Oh. 2 of these guys were a couple of my best friends. And it was sort of in the mobile space, but really what it amounted to was, I had only been on the periphery of this, but one of my friends had been, I think, one of the key architects in the Messenger product. Mm-hmm. And so we're talking now I guess maybe 90, 98, I want to say, something like that, let's say. And back then, this is, before like all this the server side stuff. This was a hard CS problem. Somebody tells you like, okay, here's what, it's 98, and this is what I want you to do. Start up a system that can maybe let, I don't know, 100,000 people like sort of text to each other with like sub 100 millisecond response time. And, and have it grow from that to 100 million users and never go down. That scalability, like performance and like just add stuff there was a tough problem. And so what we ended up doing in my startup was like, oh, that was hard. Why don't we do that, but do it as a platform to let other people build sort of real-time, scalable, high uptime apps for themselves. So we did that, and we sold it 14 months later for a bunch of money that a year after that turned into almost no money because the public company that purchased us had tanked. Oh. And us founders had been constrained. We couldn't really cover the downside aspect of that, given we were officers of a publicly traded company. It's not considered cool to bet against your own team. But still, it was a great experience. Like with a couple of pals to start a company, hire 50 people. Some of them, married and have kids. Some of them went on to do really cool multiple startups of their own afterwards. So, all told, it was really great. Mm. And between the money that I made there and at Microsoft, I had just enough money to sort of at 42 or 3 retire and simulate my current lifestyle without working ever again.
Oh, nice.
And I had a 3-year-old son, and I liked being a dad. I moved to LA and as a wannabe filmmaker, which I did for a decade with no notable success, although the dad part of my job was very successful.
Yes, I can vouch for that.
Thank you. So I went back. I did it as my second startup. Sort of got the band back together and did a second AI startup in 2014. Okay. Which was a little bit early. Should have done that 5 years later.
Right. So AI how?
So the thing it was called Surround, and the thesis I'd say of that company was this. This is like early Raspberry Pi days. Mm-hmm. So like little $30, $25 computers, pretty darn capable. Oh yeah. For what they are, capable enough that they could do inferences of AI models. But again, this is LLMs are probably 4 years away, maybe 5.
Yeah, the Transformer paper was 2017, 2016,
exactly.
Like that.
And even after the Transformer paper, it's probably another year before all of a sudden the magic sort of showed up. But what we thought at that time was, what would be nice if somebody made sort of a platform infrastructure that allowed you to deploy models to these edge devices that are super cheap, like run inferences to do something useful, but also capture the data that you send back to train models for the next stuff. And so the idea was to do the back-end stuff and the edge stuff to do that. So it was pretty hand-wavy. We spent a bunch of time trying to figure out, I forget where I heard it. Somebody once said to me, like, because I had been the platform guy for a while, somebody had made this metaphor, which is like, platforms are a little bit like ropes. You can't push them out. They need to be pulled out into the world. And so you're obliged, if you're making a new platform, to create like the killer app, something that justifies why all this code is useful for something. So honestly, we struggled for a while to try to come up with like, what would be the useful thing? Came up with some interesting ideas, built some prototype stuff. Didn't go anywhere until it was actually another friend of mine's company had been a going concern for, 11 years. Mm-hmm. And unlike my little AI company, this was a company with a real business model. They made software for Toyota head units. They had, multi-$100 million, multi-year contracts to do that for Toyota.
Okay.
They had been, they had a brand new CEO who was really tasked with the investors were a little fatigued. Like, hey guys, it's been 11 years. When you seem to be doing really well, when do we get like our return?
Right.
So his job was really to sell the place. And the very first thing he did was find us and decide, oh, you know what would help sell this? Let's sprinkle a little AI fairy dust on this company. So what that did was it did give us our app, though. Now we're doing this thing for the automotive space.
Okay.
And we ended up merging with that company, my little company and this larger company. We merged, and then we were doing automotive software stuff. I was doing, over on the AI side, I was doing things like an inward-facing camera that would detect driver impairment.
Right.
Would keep track of, like, when's the last time you checked your mirrors, or like, are you texting, that level of stuff.
Oh, interesting. Yeah.
We were also playing around with, like, we had contracts with cars that were like generating massive amounts of data about where the car was and and what it was doing. So there was obviously some stuff there to how to aggregate that stuff and maybe train models on it to make useful things. But mostly, then I was at this bigger company whose job was still to be sold. So then I was sort of just like a graybeard who could sound like he might be smart and talk about the cool stuff we were doing, which we succeeded. We then, a couple of years later, sold that to the world's largest maker of car seats. It's Lear is the name of the company.
Okay.
And they also did a bunch of automotive electronics and various stuff. But this was a pretty big fit in that it was different than what they did, but completely in their space. Mm-hmm. And so, yeah, they acquired us, and that was.
And you could retire again.
And then I worked there for another year or so, and then I retired again, and that one has so far stuck.
Oh, good.
Yeah. So yeah. So anyway, I've been just incredibly lucky. I mean, when I think about the little forks in the road, I feel like without my mom having that client who's the head of an R&D department,
right?
I don't know. I mean, I swear I definitely still end up being a little nerd, but it set the course of like, oh, you know what? You should get paid to do interesting stuff that you love.
Yeah, there's always like places like that. For me, there was a teacher in high school who realized that I was good at math, and she pushed me, and I wound up, taking calculus, getting AP credits and stuff, and so she helped me to get into college. I had no idea what all that stuff was.
Wow.
To the point where like I was missing some course to be that was required for calculus. Over the summer, she gave me the book, said, do these problems, send me right.
Independent study. She just created it for you.
Yeah, and we would correspond. I went back to Europe that summer, and I would write the stuff out. She would look at it, send me. So it was really cool. Yeah. No, I mean, I think everybody must have, those little paths that happen there, including obviously like, I met that person who became, co-parents with me, and I don't want to have my kid without. Which is one of the reasons for this podcast, because I love to hear these kinds of stories. So the last question I usually ask.
All right, shoot.
If somebody's starting in this field today, what would your advice be?
Well, boy, it's a tricky time, isn't it? With so many jobs feeling like they might be dramatically obviated by AI. I will say I have some. If I have some generic advice, it has to do with all the goodness that happened to me was really around the people that I ended up working with. Like, I feel like just try to, like, if you can weasel your way into like the smartest, most interesting group, that's like, it's probably more important than what job function you're doing, is to be around these people. I just got incredibly lucky, and I feel like that early luck, it set me up for the subsequent luck, right? It's like we're getting chosen to do the browser, it's like, one of the ways I describe it is, like if I could have gone to Microsoft and ended up being at Word, the developer in charge of bold, and then I'd be touting, my patents on like, fractional stroke width and ligatures for, there's nothing preordained about like, oh, I landed and got to do really cool things. But if I look at why I got there, it's because of the people that I either was lucky to land with or chose to. I chose to leave and do a startup with that set of people because it felt right. So that probably is my biggest advice. I mean, a lot of people, when I'll mention, because I'm a big believer in like, yeah, it's luck. I was, we're both talented engineers, but there's 4 million of us. Or however many. We're just,
Well, one thing I think about is there's lots of work to be done. So, don't think that you have to go to a particular direction because there's interesting stuff happening all over the place.
I agree. Exactly. And even stuff that might seem on its face boring, like you can make it interesting.
Yeah.
So, but it is true that you do need to be, if luck were to happen to you, you do need to be prepared to take advantage of it.
Right.
So it's not an argument for just wait for the universe to deliver you something. You do need to still work. But man, I'll tell you, for me, like to be lucky enough to get paid to do something that you love doing, man, I feel like not a giant slice of the population gets that. And I was super lucky. I always felt like I'm not curious about you. I can remember, because I started so young, I can remember when I'm like 35 and I've been doing that for 20 years, like paid doing it for that long, thinking like, oh, at some point I'm going to get jaded. And like, it never happened. Like, I still like building stuff. It's fun,
Right.
What about you?
The same. So the whole thing about this field, we lived through the explosion from when we started, in my very first job at Irving Trust, we were excited when our development machine got 4 meg of memory.
Yeah.
This is like exponential explosion, and it's kind of, some of the stuff is leveling off, but there's other things happening. So,
yeah. And not to mention the waves, right? That's the other thing for me. I feel like I was so lucky to be like, I was sort of like early on in the PC wave, right? And then I was certainly on the internet wave. My first startup was sort of that mobile wave. My second startup was AI.
Right.
Like, who knows what's next? But man, there's so much cool stuff happening.
Right.
And scary, but
at least we won't be bored, right?
Exactly.
The story I tell people is that when I was a kid, I used to love to read about explorers, like Arctic explorers, Africa, Americas. And then I got sad because the whole world is already explored. But all of a sudden, here's a field that it never ends, right?
Exactly. So, and the universe of ideas can be explored, and that's probably not bounded at all.
Yeah, just like right now, I'm having fun learning how LLMs work.
By the way, how is that going? What do you have any early insights? Like you saw something and you're like, oh,
yes.
Tell me.
The thing about language modeling, right? You take your dictionary of tokens and you map them to embedding vectors, right? And it's not clear where those come from. Now I know that they come from, and there's like a separate step that you do that you can train a neural network, very simple networks with just like one layer. Basically, you feed it like 3 words, and the 4th word is a target on your target text. And after you train this network, predicting what the word is of the 3, the weights from the network are your embedding vectors.
Those are the embeddings. Okay.
Yeah. So, and the whole notion of transformers is that the vectors of forwards that kind of belong together are kind of close together in some
Okay.
sense, however you measure vector closeness, right? And in the transformer, the insight was that you use this attention mechanism to move things around. So the typical example is like you can say, I ate an apple, or I rebooted my apple. Or one apple is close to food, one is close to a computer, right? So
Right.
so that's what.
And
that's
then the
kind of
embedding
stuff.
is this multidimensional space that
Right.
allows those two. It lives in both of those.
Right, but the attention
pieces.
mechanism actually looks at the input and moves the vectors around so that based on the context of your input, they get moved together.
So on that embedding, so when you say there's 3 words and then the fourth one is, do they do things like filter out like articles and simple things to get like important stuff closer together for those? Because it seems like a lot of times if you had a V and a then
No.
I mean, obviously those can change the context, right?
Right. But that's the kind of mystery of language, right? That and they don't even consider the order and the training of the embeddings. So
Is that right? Okay.
yeah. And the methods that I've read about. So there may be new ones.
Right.
I'm not up to date on this stuff.
No, I mean, I read a bunch of stuff on the current stuff they're doing, and it's pretty crazy. Like when a training regimen is like, oh, okay, it's gonna cost $100 million, and we're hoping it works.
Right. Well, I think that was an accidental discovery at OpenAI, where they realized that if you can make these models larger, then all of a sudden you get this great behavior.
Right.
But then it's the assumption that you can continue making them larger and it'll improve. And I personally believe that's wrong. Right. But you can look at another technology, history of, let's say, aviation, which is my other favorite subject, is there was very exponential growth of like in speed of airplanes, and was 1907, Wright brother flew at like 20 miles and 30 miles an hour. By 1939, you were doing, 200 miles an hour. And the people assumed you could continue. And then you discovered there was a sound barrier. And so.
Right. No, it makes sense. So is it your impression then that we may be reaching a plateau on these AI systems? Or?
On LLMs.
On LLMs, yeah.
I believe so. That's my intuition.
Yeah, I sort of feel like the shape of those networks, I mean, obviously they're immensely powerful, but it'll be novel shapes of networks that will unleash the next big chunk of stuff.
All right,
man.
Well, this was great conversation. Thank you so much.
Oh, thank you. It's always nice to talk to you.
Okay, well, come back next week or next month and then for next person.